Welcome to CO2 Mondays with Trevor. I'm your host, Trevor Matthews, and I'm excited this week because I got a good friend of mine and a really excellent person to have on the show to talk about CO2 today. My good friend, Brett Wetzel. Brett's from a company called CoolSys, and he's half of the Advanced Refrigeration Podcast. So I'm excited to have this conversation with you, Brett. Brett, welcome to CO2 Mondays.
Thank you very much, Trevor. I appreciate it.
Awesome. So, Brett, why don't we start off and tell the audience a little bit about yourself, what you do, a little bit about your background, and a little bit about your background on CO2.
All right. So my name is Brett Wetzel. I'm the manager of technical troubleshooting and training. Some of the things that I do for CoolSys is I go out to sites that we might have problems on, across the country and help assist with, getting a resolute for, anything we might have out there, going over new technologies, making sure I'm staying up to date on all the new technology coming out. So in case someone does have a problem, I can help and assist them, fix that stuff. I deal with all the training schedules, the budgets, and also working with people and going out and making content, simple videos, how to check superheat, how to check subcooling. I have a lot of manufacturers meetings that we've been doing, basically going through a slide deck, and I just sit there and ask questions that I know that I'll get, and then that way technicians can listen to the conversation and maybe hopefully pick something up. I've been in the industry about 18 or 19 years. If you count my electronics background, I originally went to school for electrical engineering. I realized that I didn't really enjoy what I was doing. Somehow got a job doing water treatment for industrial cooling towers and boilers, and that was the end of it. I started talking to some mechanical guys and started going to school part-time and worked on anything from a 5-ton mini split to 1,000 horsepower ammonia screw. Like I said, I'm continually always learning. Personal development is very important to me. Making sure that you're trying to be the best of what you can be. This industry is a great industry, and it will help take care of your family, if you put in the time for it.
Yeah, for sure. And I love all the experience, right? You're so well rounded. And that's what I see in a lot of good technicians. They work on a lot of different things and then really specialize on a few things. And it's good to have that experience working on those different types of equipment because it helps make you think a little bit differently when you're working on something and continue to invest in yourself. I love seeing that. I love seeing technicians continue to grow their knowledge throughout their career. So let's get into CO2. So when was the first time you seen a CO2 system in the field?
You're 7 years.
Testing your memory here.
About 10 years ago,
Wow.
Up in New York. I used to work for a company called AAA Refrigeration, and that was the first time I've ever seen a transcritical rack.
Awesome. So what types of CO2 systems have you worked on? Because there's quite a few different ones, right? You got secondary, you got Cascade, you got Transcritical. Which ones have you worked on in the past?
So I've worked on a bunch of Cascade, where basically you're utilizing the saturated section of the high stage, which would be your medium temp compressor, in order to get a certain saturated condensing temperature. So the way it works is, you're using your HFC or HFO refrigerant as a cooling media to basically be the condenser, for your CO2 to condense that vapor back into a liquid. Now, one thing with, like a Cascade type pump system, it's amazing because, you don't have the extra heat of compression. The only thing you're really doing is, that refrigerant is forming back into a liquid. You're pumping it out into the system. There's no, when it comes back, there's no compressors damage. It's, circulating with a centrifugal pump. So there's no heat of compression. So no added additional, taking away superheat there. And, there's no metering devices. I mean, it's a solenoid that basically opens up to a distributor, and that's really it. Then you have, your other types of Cascade, where you're utilizing the suction temperature With compressors, you're still trying to maintain your discharge or vessel pressure, but basically that's how you're controlling your head pressure essentially, or your vessel pressure is by the HFO. So if you're running, let's just say we're running 18 degree saturated suction temperature on our HFO, our 448, our 449. Usually the exchangers have about a 7-degree delta. So that gives us about a 25-degree liquid temperature. And then that turns into about 440 PSI on CO2 side. And that's basically your vessel or discharge pressure. And that's how they're controlling it. So they don't have to have a gas cooler.
Yeah. So I worked on some of those too, and it was really funny when I worked on, I guess, in my first secondary CO2 system, when I walked up and I looked at the suction and liquid line, and they were the exact same size, which really was like took me off. I'm like, because I've always used to, a smaller liquid and a larger suction.
Mhm.
And there was a few times after an install that I would go back and all of a sudden one case wasn't working because the lines got crossed, the 258 lines or whatever got crossed.
Mhm.
So that was something that was real interesting when I first started seeing those systems.
Mhm.
What are some of before we get into like the transcritical stuff, what are some of the service calls that you would have had on, say, a secondary or a cascade system?
So one of the biggest ones that gets overlooked a lot is, when you end up having, and this ends up happening because of either poor practices or not understanding, everything about CO2. In these exchangers, they usually sit on top of the pumped liquid variety of Cascade system. You're basically taking that liquid that condenses in these brazed plate heat exchangers and running it through these centrifugal pumps, running it out to the system, and then bringing it back. And they actually don't refer to it as a straight up suction. They refer to it as a wet suction, and this is saying that it doesn't have your typical grandma's 20 degrees of superheat, right? Coming back. The superheat can be 3 degrees. It doesn't really matter because, like I said, that liquid's going to drop to the bottom and get recirculated. And any vapor that is going to rise to the top is basically going to go in those heat exchangers and then get recondensed. That's going to drop to the bottom and then cycle repeats. One of the biggest service calls you'll get, and you'll look like a hero when you figure this out, because chances are we probably had 2 or 3 technicians look at it and it was working intermittently. So what happens is if you get any kind of non-condensables on your HFC side, or I'm sorry, I'm sorry, on your CO2 side, whether it be, because someone didn't do a proper evacuation, or maybe they didn't get rid of the helium cap charge that's in a lot of these tanks. So they, when they had a massive leak, they ended up putting a bunch of refrigerant in there, but they also ended up putting that little bit of helium cap charge in there. Well, that's going to rise to the top, just like any other, air and refrigerant. It's going to settle towards the top. Well, if you take up surface area on there, you don't have the full surface area of the exchanger to actually, bring your pressures down. So in turn, what's going to happen is, you have to end up purging out that top section of the heat exchanger to get your surface area back. And a lot of times, I've usually seen these, the Cascade pump liquid with either 2 or 3 heat exchangers. Typically they should be running within 5 to 10% as far as expansion valve percentage. If they're all set for the same superheat and all the sensors are correct, and there's no, bubbles in your sight glass, that you are ensured that you're getting a solid calm liquid, you should be able to maintain. And like I said, if you have those non-condensables in there, you're reducing that surface area, and you won't be running this same exact expansion valve percentages. You might have, on a properly working system, you might have 45, 45, and 45. On one that has, non-condensables in it, you might see 35, 15, 5. And, first things is you want to make sure you have enough liquid. And once you verify the liquid, the temperature and everything like that, then it's something else outside the system. And that's when, usually see that it's non-condensables. Another thing that happens in this system, on the pump liquid variety, on the HFC side, because it's running such a lower superheat, and because it's running such a low saturated suction, any kind of moisture in the oil will actually go into the heat exchanger and sometimes freeze up in the secondary heat exchanger. So what has to happen in order to get that working? You'll see kind of like what I just said, where the expansion valves won't be at the exact same percentages or within that 5 to 10% rating. And what happens is ice builds up in the heat exchanger that's typically after the braze plate heat exchanger, just to ensure that you're not, getting that 8 degrees of superheat back at your compressors. They have a secondary heat exchanger to kind of help with that a little bit and to help subcool the liquid just a hair. And what happens is moisture builds up in those heat exchangers and you will have a pressure drop. And that's what you'll see. That'll be your spot in the eye that where you're seeing that, hey, I have a problem. Because I mean, if your suction line is only 10 feet, basically at the heat exchanger it should be about the same pressure at the rack suction. And a lot of times what you'll see 8 pounds at the suction at the header, and then 8 pounds on the transducer at the heat exchanger. But then you'll go down the line and you'll see this heat exchanger is running 12 pounds and the rack is running 8 pounds. Well, that's odd. If it's running 8 there, I mean, how can I be higher or lower? And the reason why is because that oil or the moisture in there will actually freeze and create a pressure drop. And what I've had to do in the past is close off the suction line coming out of that after the braze plate heat exchanger, letting the pressure come up. So I'm letting the liquid line feed, keeping the suction closed just to raise that above freezing. Once it gets up to about 40 degrees, I know ice melts at 32. So technically any of that ice that would have formed in that heat exchanger should have been melted. And then you basically open up the suction line, then you'll see that pressure drop has went away. But that's 2 instances that you will see out there when you're dealing with with pump liquid cascade. Those are 2 big calls. Basically your rack isn't maintaining suction a lot of time because of that.
Yeah, and I love that because that goes all the way back usually to either day one installation or a major service repair that had to be done on the system. And continue talk to technicians about that day one installation is so important. Don't just, okay, I let the vac pump on for an hour, it's good. You need to use your micron gauges and make sure it's pulling down below 500, below 300, below 200. And what I love seeing, I see more and more technicians on social media putting up how low they can pull down systems. Like there was one today I seen on Facebook, a guy pulled down a rack to like below 100 microns. So it can be done. You just need to know how to do it and need to know the processes to get it as low as possible to make sure there's no air in there, the oil's not contaminated. So, and this doesn't really matter for any type of system, CO2 or synthetic refrigerant. So thanks for those great points. What about Transcritical? So you said you worked in some Transcritical stores. What are some things you should look out for on a service call? If I'm a new technician and I've never worked at a CO2 store before and I'm on call, what are some of the things that maybe you should look out for, you should be thinking about if you get onto one of those service calls?
So, one of the things you want to be really concerned with is the abatic condenser, or I'm sorry, abatic gas cooler. You need to call it a gas cooler because it's not actually, once it hits that supercritical point, it's not making liquid anymore. There's different processes that they're actually doing in order to create liquid. But making sure that abatic tower is clean. They have water pads on there that the water drips down. Basically, the principle is that by lowering the air temperature falsely, by basically lowering your dew point, by putting water over these panels, you're able to achieve a smaller TD on your condenser, which will limit the amount of time that you're in supercritical or transcritical mode.
Yeah. And that's super important because when you're in those warmer days of the year, you're going to be in that zone unless you have some sort of high ambient strategy like adiabatic cooling. But I haven't seen many of those here in Canada per se yet. I'm sure there are some. And it's a technology that's starting to evolve even more and more depending on where you're at, because it's not a great solution in all locations, so it depends on where you're at. But what are some other things they should be, like a technician should be looking out for when servicing a CO2 system?
get familiar with the rack. Knowing where all the lines go is imperative. How they're trying to control it, and if you read Husman LMP rack IOM, like it tells you step by step of how this rack is supposed to operate. For the most part, it's I look at racks as candy bars, right? It's still the same Snickers inside, but you got a different wrapper on the outside. It's still the same theory. It's still the same principles. They're just doing it just a little bit different, from store to store, but it's really not much. New technologies are coming out all the time. I tell all the technicians that I train with, they should, at least one item a week, just one. Look up one item a week on whatever you're working on, and look up all the bits of information about that one thing. You will learn 52 new things in 1 year, and you will make yourself more valuable, and guarantee there's going to be one of those components that you're going to look up during that time that you're going to need to know at 2 o'clock in the morning, because you can't get a hold of someone. So making sure that you are, fully, understanding of how the piping works. When I put on training seminars on site, we don't even look at the rack. The first thing we actually do is look at the refrigeration schedule and look at the piping diagram, because I'm gonna show you something right now. So let me share my screen real quick.
Yeah, go ahead.
So this right here is a picture of a transcritical rack. As you can see, there's a lot of stuff going on in that picture. So trying to understand it like just looking at like this is extremely confusing. It's confusing for anybody. Thank goodness that there's the whole bunch of arrows on there that are basically telling you if it's liquid or suction and which direction it's going. But this is why, I recommend looking at the refrigeration schedule as well as the piping diagram. And I'll show you why here in a minute. So we saw that, and now we're going to look at the actual plan. All right. So that rack that I just had the picture up is basically the same thing as this. Does not look like it at all, but even this way, it looks like there's 1,000 less pipes in this picture, right? Versus the picture. But this print actually breaks it down. So like I said, when I'm teaching a class, we're going through, okay, which one's the discharge line, which one's the suction, and literally just going through line item by line item, so they fully understand of how everything's put together and the sequence of operation, how the flow of the refrigerant goes as well.
I think that is key what you said there, and I don't think enough technicians do that, even on regular synthetic refrigerant racks or systems, even chillers, I would say, and packaged units. Like, more technicians need to take the time to go step by step, just like you're saying there, Brett, because when I do my trainings, I do the same thing. Is I get the technicians to go right from the discharge of the compressor. Okay, let's start here. Where is this line going, and why is it going this way? And the flow to the oil separator, and then from the oil separator, I got 2 lines going from the oil separator, okay, to my gas cooler condenser, and down my oil feed line. And it's so important to do that, especially on these systems, because you just seen a picture that Brett showed where there's dozens of lines going all different ways. It looks like spaghetti against the wall. But when you take your time, like Brett's saying, and you take the refrigeration schedule or this map and then compare it to there and slowly walk through it. Don't rush it, especially when you're on a service call. Like, really, I keep telling more technicians, when you get to a service, take your time. Don't rush through it. You rush through it, you're going to make a mistake and you'll be there longer. Take your time, think about it, understand the equipment you're working on. Yes, you may have not worked on a CO2 system before, but once again, it is refrigeration. And just really think back, well, what are the basics of refrigeration? CO2 does have some uniquenesses, but if you go to that legend, they should have it at most stores. But I think all the CO2 stores do have it now. But most refrigeration stores on synthetic refrigerant should have a legend as well, just like this refrigeration schedule. So keep going, Brett.
So, exactly what you were saying, like as you were going through, I'm like, okay, discharge line, following that line all the way through. Right. And, just follow, you're basically just following the map. You're utilizing this, to basically understand, You're utilizing that to understand this. And like I said, this is a heck of a lot more complicated looking anyway. It's the same system. It just, having everything laid out in front of you. And that goes with a lot of different things in this industry, understanding programming, the same thing. And that's one of the things with CO2. There's just more controls. There's a lot more controls because there's a lot more, safeties that are involved, right?
Yeah.
We're dealing with a little bit higher of a pressure, but for it's basically it's all the same principles as regular HFOs, HFCs, just a little bit of tweak here and there where it's just a little bit different.
Yeah, and that's for sure. Like even like subcritical side is identical. The pressures are like kind of like 410A. I tell technicians, it's like the subcritical is like 410A. So if you worked on 410A before, you're like working on a CO2 subcritical side. Transcritical side now, depending on where you're at in the year, if it's really warm, you could be in transcritical. Even in the winter, you could be in transcritical if you're using heat reclaim or reusing that heat. But it's important to take the time to understand that system that you're working on and not to be afraid, but to ask questions. That's the big thing. If you don't know, it's okay to ask questions. There's a lot of people like us out there that want to help and share that knowledge. Because when you're on that first service call, I've been on my first service call and my first on call before and walking in at 2 o'clock in the morning and nothing running and my heart pounding. But after doing it for so many years, walking into a call when a rack's not running wasn't very intimidating anymore. You know what I mean? Okay, well, I know everything's down. There's no power to the rack. Okay, why is there no power to the rack? And you got to think about it and then slowly analyze what has happened in that service call, for example. Okay, so I know I had calls like this from my buddies before, but what happens if a service technician gets a call to a store and all of a sudden they figure out, they look in the sight glass, there's no gas, it is empty. What is the process to add gas to the system? And is there gas usually at site?
So, I mean, a lot of our sites, we do keep refrigerant on site just because a lot of times you have to get it from air gas and air gas isn't one of those, I've never opened one up in the middle of the night and nor do I want to. I mean, I'd rather just open up, like a United refrigeration or something, but like, we just usually have it on site because it is critical. Like if they have a release, you want to make sure you do have that on site. We as technicians, we tend to freak out when stuff like that happens, when you have that service call. And one of the things with this, you need to treat it with respect, but still, treat it as any other refrigerant. Like Trevor said, the low stage is running 410A pressures, right? I mean, they actually put 410A compressors, scroll compressors on the smaller CO2 racks, correct?
Well, I don't know if they're ZOs for the Copeland side, and the Bitzers are semi-hermetic. So would they handle 410A for sure, but I think they're rated. I guess they're tested for CO2.
Okay.
But the pressures are the same. So I don't know the answer to that, to be honest with you.
So if you're having to charge a system, like if you were to have a major release where the pressure gets below yes, let's just say it's all the way down to 30 psi. The relief should have caught it, but in case, reliefs do stick open. If the pressure is at 60 psi or lower than that, you have to charge with a vapor. Otherwise, that refrigerant that's in the system will basically turn into dry ice. So you want to have a couple, in case of a catastrophic failure, you want to make sure that you are using a cylinder that does not have a siphon tube, because that's really the only difference between a vapor cylinder and a liquid cylinder is the siphon tube. In a pinch, can you turn a liquid cylinder upside down? You could, but it's not really safe. It's not recommended that you do it. But like I said, so when you're charging from a system that's completely flat or the pressure is extremely low, you want to get that pressure up. I always tell everyone, just get up to 100 psi. You don't have to mess around with 70. It's like 68 point something, but just 100 pounds. Get the vapor pressure up to 100 pounds. and then charge it with liquid. When that kind of failure, you're going to be hooked up to the rack. You can charge directly up to the flash tank. You could do it that way. If you're just a little bit low on CO2 and you don't really have to add all that much, and a lot of times these racks do have a charging line. I like to cheat the system. I go down to one of like a 2-door case, 2-door frozen food case, because the suction is going to be the lowest at the rack anyway, so it'll go in faster. But then on top of it, what I do is I hook up to the liquid line. So I shut off the liquid line ball valve. I let that refrigerant boil off, because now I'm not adding any additional CO2 to it. So anything that's in the liquid line and or the evaporator is going to boil off. And I basically attach my gauge set directly to the liquid line. And now I can just open up that line and not have to worry about flooding back. Because what's going to happen is the evaporator still has a load on it, especially if I'm keeping the doors open. So you're going to have an expansion valve that's going to meter that refrigerant through anyway. So I don't have to worry about, potentially, one of my compressors up there taking a liquid slug. Because imagine if you get on site and you find it's flat and you're like, oh, this is easy. And you go charge it up, and then you end up taking out a compressor because you got overzealous with charging it. And that's with any system, that can happen to any system. But like I said, with the CO2, that's the way that I add it. It's easier that way. And then you don't have to worry about, you can basically set it and forget it and just let the cylinder empty out. Because you don't have to worry about, any of the suctions taking a liquid sled at all.
So, and that's one thing is like working and servicing on a CO2 system is no different really than working and servicing a synthetic or HFC system. Your service calls are going to be very, very similar. One thing about the CO2 systems, there's just going to be a lot more electronics, and you need to understand controls a bit more. But even on the service call, when something does happen, when you understand like refrigeration, the basics of refrigeration, what's going on, that coil's frozen. Well, what causes a frozen up coil? Did the defrost come into play? Did it not go into defrost? Was the airflow plugged? It's going to be all the same things. And I know I talked to a lot of technicians that get kind of flustered because it's, okay, this is a CO2 system, it's not HFC, so higher pressures. But in the same area, it is still refrigeration, commercial refrigeration. So all the processes are the same in the sense that when I'm servicing and I'm going out to do a service call, I'm thinking of refrigeration. Doesn't matter what refrigerant's in the system. And that's the way what I try to tell technicians. Yes, everyone talks about CO2 and I think maybe puts a little bit of fear in people, but there's nothing to be fearful about, because when the systems are installed, and I know the manufacturers are working really hard to make it very safe for if something shuts down, you have enough pressure reliefs to release the gas outside the system, or the system shuts down on a sequence itself in the control system. So it's really important to understand that. And it all goes back to what Brett said earlier, is take each day or each week, learn something about a CO2 system. If you're starting to read that manual, because I know 95% of the technicians out there are not reading that CO2 manual or that comes with it. And if someone takes it, they're not doing the research to find a manual. It's so easy to find these manuals now online. We're so lucky to have that opportunity for that. But yeah, so charging us or adding gas to a system doesn't sound much different than an HFC system, besides if you lose the whole charge, you need to add that vapor, like you said first. So what about if someone gets a service call and just say they have to replace a coil, say out of an evaporator? Because I'm assuming that these cases are similar to an HFC case. Is there any differences?
There's actually less copper. Yeah, there's because CO2 has more BTUs per pound than 90% of the refrigerants out there. I think the only one that's higher than is ammonia. But because they're so efficient, they actually have less copper in there. So when you're isolating the system, you're gonna obviously close off the liquid line. You don't have to necessarily put your gauges on, but if you do, it's like I said, it's only 410. So on a Cascade system, it's CO2 410A pressures. But basically shut off your liquid line, let the entire liquid line shut down, because on the main lineup, that's, if you have 3 different cases on that one lineup, basically that one is going to shut down everything just like you would on any other system. The only difference is you're going to ensure that you have no more liquid in the system. And, we all know how to do that. Basically shut off the suction line and see if the pressure increases. And that'll prove that you have more liquid in that system. So a lot of times if I'm isolating a case to defrost it, I'm shutting off the ball valves, shut off the liquid line first, and, basically get it down to suction pressure. And at that point, it should be all vapor, right? The evaporator should, the expansion valve should let whatever refrigerant through, and now it's all suction gas. So the fact that it's all vapor, that means legally by EPA, we can blow the rest of the charge that's in that system. You could assist and try to get the pressure down a little bit more, but you can't use a recovery machine on the CO2. So you just blow whatever's in that evaporator. Then once you go to fill that, once you replace the coil, you do everything you would the same as HFC. The only difference is you're going to open up the suction first on that system, because if you were to potentially just open up the liquid line, you could potentially form some dry ice, because you're going from a vacuum instantly to 200 pounds. And in an evaporator, you could have some rapid expansion and destroy that coil if it were to happen. So once again, don't be afraid of ammonia, but respect it. Know the rules. Know the things that the little idiosyncrasies about it. One for instance, dealing with different refrigerants. So I've dealt with ammonia in the past, and liquid refrigerant will sit on the bottom of oil. Well, not in an ammonia system. It acts inverse. The liquid refrigerant will actually sit on the top, and the oil will actually sit on the bottom. Just those little idiosyncrasies with the different refrigerants, and that goes back to reading. Another thing you could do to do yourself any favors is go on any of these webinars. Yeah, I guarantee if you look right now, I'm actually signed up for the IHACI CO2 training class 1 and 2. I'm one of those type of people where I might not learn everything watching one video, but then I might pick up something else, and then something else, and then something else. And then here I am, more well-rounded, because I took the initiative to, invest in myself and do some personal development.
Yeah, that's awesome. I like to definitely investing in yourself is super important. But I want to go back to what you said there about how to service that coil. Is like you shut off that liquid line, like you said, but after you do the service, you pull down that, you evacuate that coil. Just say you have to do a repair, there's a leak, and you pull it down below 500 in holes. You slowly open up the suction, and always be open. And it doesn't matter if it's synthetic or CO2, you want to be opening valves slowly. I know when I first started out, I would just open them super fast and I go, shh, and just nobody taught me until I started realizing that puts a lot of force on the system. So open the valves always slowly in CO2. Do the suction first, then do your liquid. But I did the same thing in a synthetic store. I always open the suction first. So it's important to understand that a lot of this is the same as the stores you're working on right now. If you're working in any of the commercial supermarket CO2 booster system or transcritical systems. So I know it's real important to plan maintenances and shutdowns for CO2 transcritical stores. Why don't we talk about if you have to plan a shutdown? Maybe it's to do a repair. Maybe it's to change the oil filters or liquid line filter dryers or suction filter dryers, whatever it is. What are the steps to doing like a planned shutdown?
So if you're going to be shutting down the whole system, you're going to have to shut down the liquid to the low temp compressors first. And the reason for that is a transcritical booster system can run medium temp alone, but it can't run the low temp by itself. Because if in a booster system, you're actually discharging the discharge gas off of the low stage into the suction of the high stage or medium temp. So without those compressors on the high stage doing their duty, you can't actually turn the low temp on by itself. You need to be able to so when you do a startup on one, in the manual, it actually tells you do not start the rack with anything under 40% of the load on either side, and medium temp always has to run first, and for that very reason that I just explained.
Yeah, and that's a good point because you always have to on these systems run that medium temp, and it depends on the manufacturer. They're going to tell you different ways on the startup. So some will say, okay, we want 50% of the medium or transcritical side running, then 25% of the low side, 75% of the medium, 50% of the low, depending on the manufacturer. But you always have to have that transcritical side running first, or you can run into some issues.
So one of the things be mindful that does, we did talk about controls, how, controls makes, these racks a little bit more intricate and a little bit more difficult to work on sometimes. But as like I said, as long as some of these sequence of operation things, it makes a lot more sense when you understand it. So with whether it be transcritical rack or subcritical rack, it doesn't matter. When you have a high pressure situation where you actually have a shutdown, you will have a sequence of operation for those cases. Typically, it will get the rack back up and running. Typically, it'll get your medium temp up and running first, and then you would have to have a 40% of your medium temp rack running before you actually start your low temp. But one of the things that internally in the programming, especially when they're utilizing E2 or E3, they have either a flexible combiner or some sort of timing circuit that when it does have a master shutdown, it will actually shut down all the enables on all your case controllers, or, it's going to shut down every single case. Because, if you're going to start a store up after being shut down, there's going to be a tremendous load on that rack because of the BTU exchange. CO2 is, X amount of BTUs per pound. It's one of the most efficient ones. And so if we turn on everything all at once, a normal HFC rack might be able to take it. CO2, probably not. So what they do is they actually stage each one of the cases on usually every 3 to 5 minutes. So, right after a failure, everything is shut down, basically one master enable, shut down everything. And now that, it's re-enabling, it won't allow it to go. This one will run for a minute 20. And then once it gets down to set point, it'll kick to the next one and kick to the next one and kick to the next one. And, it might kick on 2 or 3 cases at a time, maybe not just one, but just be mindful, like after a shutdown. I remember the first time seeing a cascade after a high pressure situation. And I'm like, why are all my low temp cases have a set point of 32? I just saw it 2 seconds ago. It did say 0. I think I'm losing my mind. And basically what that enable does, it basically changes the case temperature set point, from whatever the temperature is, whether it be -10 to 32 degrees. So in that way, if it's still not enabling, it's still at least going to pull down to that medium temp temperature. So the load coming back to the rack isn't astronomical. I also had another shutdown where the rack was down for a day. We lost a pump at one of our stores, one of the centrifugal pumps, and one of the other ones was bad. And so we had no pumps. So we had to get a truck to, fill it up with product. But when I started that rack back up, all the boxes were at least up to 60 degrees. So I tried doing the regular 5 minute, 5 minute thing, like one circuit turns on, then the other one circuit turns on after 5 minutes. I had to wait until it hit below, I think I stopped it at 20 degrees. So once the temperature got down to 20 degrees of the case that I was trying to pull down, then I would go to the next one. Cause I found out if I was above freezing, like if I was above 32 degrees, it was too much of that latent heat load coming back, wanting to get cool. And it was just too much load on the rack.
Wow. Yeah, and that makes sense too, because when you get too much load, your compressors are just not going to be able to maintain. So doing the planned shutdown is so important. Understanding these sequences. So if you know you have stores at your company that have CO2, you should be asking whoever the lead technician is at your company about what is the planned shutdown? What happens if I have to shut down a store? So you got to remember, okay, I got to shut down the low temp first. Because I had technicians who've been on call before, and they told me in trainings like Trevor, I went in and I shut down the medium, just like I would do on an HFC. I just started shutting all the breakers down, and all of a sudden I hear. So you know what I mean? So they blew off the charge because they didn't know just turning off all the breakers on the compressors, which you should be doing in a different way, but they were just shutting them all down, and they lost some of the charge. It's important to understand these planned shutdowns and maintenances. Some stores will have auxiliary cooling as well. So you'll have like maybe a generator or a condensing unit that'll cool a brazed plate heat exchanger that's going to keep that CO2 cold so you can work on the system longer. But I'm hearing more and more from technicians out there, there's not many of those out there where there should be.
So off of and it's not to keep the rack running by any means. The only purpose of it is to basically get that pressure down below where it's actually going to relieve. Like they're using a medium temp compressor on the system that's running that brazed plate heat exchanger. It's usually on the outlet of the vessel, and that's only just to make sure we don't keep blowing off. They also, I knew some of the other racks, because one of the other things that happens sometimes, these reliefs that are out there are, resetting reliefs. They're supposed to reseat. Sometimes they don't, and then you end up, losing a bunch of the charge. So, the manufacturers are starting to get smarter, and they're putting in pre-reliefs before the relief. So on one rack that I was just out on, they actually, the relief on the suction, I think, was set for like 6 something when it was running in operation, and it had a pre-relief piped into that very same area, and it was going through a liquid line solenoid and a CDS valve. And basically the thought process is, if I open and shut mechanical valves right before it actually relieves, I will save my reliefs and not run the risk of having to replace this expensive relief. It prevents that from just, keep popping off. And then by the time you get there, it's not seating anymore. And, then you're in a little bit of trouble.
Yeah, I've seen a few of those where they'll have like controlled release, where they'll have electronic valve and the pressure gets real high and it'll open up and then it'll shoot out some, just to drop that pressure as quick as possible. So, and then, okay, hopefully for another 5 minutes, it doesn't raise up high enough, and then same again. So like slowly dropping the charge in the rack, but not losing it all at once. So I've seen some setups like that myself as well.
So they've put on liquid line solenoids before the CDS valves, and the reason why, so basically it's piped in wherever it's piped in, then it's liquid line solenoid, and then it's the CDS valve. And basically what's happening is that velocity is so great, and that flashing that's happening off of the tank, you're actually creating ice in there. And even though we're only max opening at like 5%, it still gets frozen shut. So your last your last hope is that solenoid shutting down to ensure that it's not going to keep that CDS valve open, right? And then you end up losing your whole charge. I'm actually looking for a picture right now so I can show you what that looks like.
So, and this is on the vapor side, everyone. So it's not the liquid side, because you never ever want to trap CO2 liquid because it expands so rapidly. So for every 1 degree Celsius or 1.8 degrees Fahrenheit, it increases 10 bar or 145 PSI. So that expands tremendously. So you want to make sure you understand the process. Never trap CO2 liquid.
Well, and that's why around all the ball valves that are down the system, that's why there's a check valve in parallel with it. So if you were to isolate it without pumping out all the liquid, or the pressure got real high in that pipe for some odd reason, it's able to actually flow that refrigerant back up to the rack. So not to have where you're creating a closed environment for rapid expanding pressure, right?
Yeah. So once again, in understanding the design of that specific system, because there is a lot of CO2 manufacturers out there and they all do it a little bit differently. It is still refrigeration, but they'll do it. Some will have lots of check valves. Some will have a lot more pressure reliefs on their system. But you want to understand that specific system you're working on, no different than working on, once again, an HFC, HFO, or a synthetic refrigerant system. You want to show something?
Yes, I have it up. Sorry.
No, it's all good. So see the picture of rack again.
Okay, so this is what we were talking about right here. This is actually the, can you see the picture of the technician with the two valve? Okay. So this is your valve, your relief valve station. Essentially, you can see, this is piped in the relief. This is piped in, all the reliefs are up above here, but they have the pre-relief right over here. So you have your, high pressure refrigerant attached to this side. And there's your liquid line solenoid. I know I keep calling it liquid line solenoid, even though there's no liquid, but just have it. And then you have your CDS valve here. But like I said, we've only opened these up about 5%, because by the time you try to open it up, anything past that, it can bleed the pressure off so rapidly that, we don't want it to go the full 6386 or 3190, whatever, how many steps that particular valve has.
Yeah, super cool. Thanks for sharing that. So these are some of the things that you really want to understand. You want to understand where the reliefs are and when they would relief, what pressures. You want to understand, you want to make sure that when you're servicing a case that you always close that liquid line, but you want to make sure that all that CO2 liquid is out of that coil. So like Brett said, you close it off. If the pressure starts to rise, in that case, you probably still got some liquid in there boiling off. So you need to open the suction and let more out. And then when you go to start it back up, after you evacuated, did the proper service, you evacuated properly, you open up that suction valve so you get vapor back in there. All these little tips and tricks are very important. If there's no gas in the rack, you lost all of it, you want to start with vapor. Super important to understand that. And once again, we go back to, learn the equipment you're working on and take small, simple steps in understanding some of that stuff.
Sometimes it's easy as going on site, and any of these manufacturers will give you the information. They're not there to hide it. It's just knowing the right questions to ask. So if you're calling Hill Phoenix, you're going to give them the job number. Same thing with Zero Zone. Sometimes it's called the submittal number. Just so what they're requiring from you. And a lot of times it'll be right on the model and serial number, usually on the bottom right-hand corner.
Yeah, no, that's fantastic. Brett, I want to thank you so much for taking the time to chat with us. Let's give the audience a few minutes for some questions. If you guys want to throw it in the chat box, if you have any questions for Brett or myself. But yeah, thank you so much for taking the time. I think these conversations, especially about service, can go on for hours and hours because there's just so many little tips and tricks that you can learn from. And when you get onto these new systems, like Brett shows some of those pictures, it can be intimidating at first, but you just want to step back and just think about, okay, well, where does this go? Is this gas or is this liquid? Is this refrigerant, vapor, or is it liquid? And then understand that specific system. Do you need to know everything? No, I definitely don't know everything, but I take the time to learn a little bit of that system. Have anything else you'd like to add, Brett?
So I heard one of the other CO2 with Trevor's, and you guys were talking about different ways that we're trying to combat the high ambient temperatures. That's why we're starting to see a lot of this stuff starting to see this in California, starting to see it in Texas. They're putting transcritical in areas where, a couple of years ago might not have been, thought of putting it there, right? So I'm going to share something with you guys. Okay, this is a technology called SkyCool. Okay. The premise is that it's using these solar panel type things. They have the panels themselves actually looks like if you ever seen a glycol seafood case. where they actually run cold glycol through the case in order to refrigerate that case. This does the same thing, except for what it's doing is it exchanges the heat from the gas cooler. This actually goes separator to the SkyCool system into the gas cooler. And the idea is that what it's trying to do is reduce the amount of temperature going into your abatic gas cooler, trying to prevent it from going into transcritical as much as possible. Because when you go into transcritical, you lose, your energy efficiency of that rack goes down tremendously. So 3M actually derived this material, and what it does is actually pulls passive cooling from the atmosphere and is able to actually drop the temperature of the discharge gas off of the gas cooler down to about 15 degrees lower than what it would be. And the colder it gets outside, the colder it'll get as well, which means you'll be running more efficiently longer and actually save energy.
That looks pretty cool, definitely.
So what they're doing right now is that they have had they've saved a lot of money with using these for subcoolers. They actually, the one I was out to go see is the first one that they've used for the desuperheating of the gas cooler. But in all honesty, there's so much stuff that could be done with this. They could do oil cooling on screw racks. They could do there's so many different applications that this thing could be used for. And in refrigeration, I think they've just scratched the surface of what could actually be done. But this is one of those things that, just be mindful. This is new technology in order to try to get these transcritical racks, even in the hotter climates.
Yeah, definitely things that you need to invest your time in and learning more about this. We got a couple of questions here. Would you do oil samples on a yearly basis?
Absolutely.
Yeah, you should be doing that on regular systems right now. You should be doing it every year. You should be checking your rack, because that's a huge killer compressors is acid in the system. But yeah, definitely do that. I know some manufacturers in the industrial CO2 side say like every 8 months they would like to see it, because there's a lot of stuff happening. And even 6 months after startup for the first year or two, depending on the manufacturer, because it doesn't hurt to take an oil sample. And it doesn't, you know what I mean? Yes, it costs maybe a couple $100, whatever it is, but it doesn't hurt, because when you make sure you got good oil, your system's going to run a bit healthier.
Yeah, if you have a system that has moisture in there, you get that copper plating on all your surfaces on the discharge, and the moisture that's in that system will start tearing up bearings. I've seen a job, we ended up having to replace 8 compressors because of that copper plating. It destroyed every single bearing. So $40 oil sample, a couple $1,000, change all these compressors. You decide what you want to do. But
yeah, I got another question here too. What is the procedure if you accidentally open the liquid first on a evaporator and cause dry ice?
So you should be able to raise the pressure in there up past the 70 psi point, and it should technically turn back into vapor once it gets above that pressure. But
yeah, so I've done it before on training systems where I may have caused dry ice because I tried many times. So all you would do is, if you do get dry ice in there, is that just open the suction a little bit, like Brett says, and get that pressure, that vapor in there higher, and it will turn it back into either liquid or into the vapor. And one more question. What is the basic bibliography to further the CO2 studies? Well, I think asking where you get more training. We'll continue coming to these CO2 Mondays with Trevor and come hang out. But really, do some research online. You'll get so much information. Just go CO2 refrigeration. Look up the manufacturers, like Brett said. So important. They got lots of information there, Brett.
So they also have, there's tons of these nonprofit organizations. The North America Sustainable Refrigerant Council. They have a extensive library where you can just look up all the stuff on their website. And they're on the cutting edge. They're involved with manufacturers that are making first gen systems like ammonia primary, CO2 secondary, which is my dream system, propane primary, CO2 secondary. Because I mean, as you know, the laws in North America, right now you can only have 10 ounces in a single system, in an occupied space, right? So what they've done to combat this, if it's not in an occupied space, then it's not, considered inside. So you can have more propane in the system. So they have a rack running, I believe it's 33 or 35 pounds of propane that's actually running a whole supermarket, which I think is amazing.
Yeah. Brett, I know you got to get going here. I want to thank you very much for spending an hour with us talking about CO2 service and installation. Really appreciate it. If you do have any questions, where can people find you, Brett?
They can find me, like Trevor said, I'm the co-host of Advanced Refrigeration Podcast. We're on all major forums, Google Podcasts, Apple, Spotify, Castbox. We have been putting up a bunch of controls videos up weekly. Kevin's been doing a lot of that for us, and showing you some of the more intricacies on some of these controls. He's actually just started last week doing a flexible combiner one, which is really, really interesting. And you're going to start seeing a lot more flexible combiners when dealing with a lot of these CO2 systems, because the formulas in order to do some of this stuff is pretty intricate.
Awesome. Brett, I want to thank you so much. Have a fantastic day. Thank you, everyone. And we'll see you next week at CO2 Mondays with Trevor. Thank you.
Thanks, guys.